So we're going to start by finding the distance between pairs of points. There's two ways you can do that. You can use the Pythagorean theorem, which we're going to skip for right now, and then you can also use the distance formula. So if you don't know the distance formula, it's on your paper, but I think you learned that in IM1. Okay, so the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Does that formula look familiar? Yeah? Okay. In order to use the distance formula, we have to have coordinate points. So let's look at number 1. What is the coordinates of this point down here? -4, -3. Okay, so -4, -3 is that point down there. And what's this point up here? 1, 2. And that's a scribble. Ignore my scribble. And we're going to use the distance formula to solve. Now, just like with the midpoint formula, I highly recommend you label your points. Okay, it's the same thing. So x1, y1, x2, y2. And second period told me that you guys actually have used the distance formula before, so that'll help. Right? Okay, great. So let's plug it in. So D equals the square root of 1 minus -4 squared plus 2 minus -3 squared. Those double negatives become positive. So 1 plus 4 is 5, which means I have 5 squared plus, these become positive, 5 squared again. And what's 5 squared?
25.
25. So 25 and 25 is the square root of 50. Now here's where things change from IM1 to IM2. In IM1, you either left it like that, or you plugged it into the calculator and got a decimal. We are going to do something called simplest radical form. Okay, I'm going to show you. So simplest radical form. What two numbers, so we're going to create a factor tree. What two numbers multiply to 50? 20, okay, 25 and 2 works. If you use 5 and 10, does that also work?
Yeah.
Yep. And you're going to get the same answer, so it doesn't matter what you choose. And then we have to break it all the way down to prime numbers. Can someone tell me what a prime number is? And 1. So a prime number is a number that is only divisible by itself and 1. Is 3 a prime number? Is 9 a prime number? No. Is 2 a prime number?
Yes.
Yes. Is 1 a prime number?
Yes.
No.
Oh yeah, it's neither.
It's like it's in a, I know I tricked you. It's in its own little category. So 2, 3, 5, 7, 11, 13, 17, 19. So any number that's only divisible by itself and 1. So can I break down 2 any further? No. Can I break down 25
Yes.
to 5 and 5? So far so good?
Yeah.
Okay. Now here's my cheesy little story that goes with this that will help you remember how to solve these problems. Because we're taking square roots, we are looking for pairs. Okay? So I see a pair of 5s. Do you agree?
Yeah.
Okay. That pair or that couple gets to leave the house and they go on a single date together. Yes, they get to go on they're leaving the house and going on a date. But they're going on one date together, not 2 dates. Like they're just get to go on one. Yes. Okay. And then this poor little 2 who doesn't have a date has to stay at home. I know. Okay, so the couples get to go out on a date. Everybody else stays at home.
I don't get it.
So this couple came out.
Yeah, but.
Shouldn't it be 10?
Oh, okay.
No, because they're a pair, but they only get to go on one date together.
Oh.
Well,
So, because.
yeah, the couple's going on a date. They're not going on a date separately from each other. They're going on one date together. Okay? Okay. So this is our answer, and this is simplest radical form. So if you are asked to put it into simplest radical form, that's no fractions, no decimals. You have to do a factor tree, pull out the pairs, and then everything else stays inside. Okay? We're gonna skip number 2 and 3 because we don't need to do 4 of these, and we're gonna do number 4. Okay. What is the coordinate for this top point? -2, 4. Everyone okay with that? What about the bottom point? 4, -2. So again, label. And we're going to plug it into the distance formula. So the distance formula says x2, which is 4, minus x1, which is -2, squared, plus y2 minus y1 squared. That double negative becomes positive. 4 plus 2 is 6. So I have 6 squared. And then -2 minus 4 is -6 squared. So 6 squared is 36. What's -6 squared? Still a positive 36. 36 and 36? 72. Okay, so I have the square root of 72. Is 72 a perfect square? No, right? My perfect squares are like 16 because the square root of 16 is 4. Or the square root of 25, which is 5. The square root of 169? 13. The square root of 225? Too high? 15. Okay, so 72 is not a perfect square. I want you to take a second, either by yourself or with your group, and see if you can put it in simplest radical form. Give me two numbers that multiply to 72. Okay, 36 times 2. 36 breaks down to 6 and 6, and then 2 and 3, and 2 and 3. What do you see pairs of? I see a pair of 2s and a pair of 3s. Okay? Just like before, if they are a pair, they're leaving. So the 3s are going on a date. The 2s are going on a date, and you're going to multiply those together. Whatever's left over stays inside. 3 times 2 is 6, radical 2. So anything that, if everything comes out, all of those get multiplied together. If there's more than one thing inside, those get multiplied back together. Because we broke them down by technically division, right? We divided them up. So to put them back together, you would multiply. Yes? Okay, so if you have an equal number of pairs. So watch real quick. So this is where you're going to get an equal number of pairs. Do you know what the answer is without me doing any work?
Yeah.
6, right? But if I break it down, I have a pair of 2s and I have a pair of 3s. So if you have an equal number of pairs, like everything comes out, it was a perfect square to begin with.
What? Say that again?
So here, I was asked, what if you have an equal number of pairs? So like everything comes out, it was a perfect square to begin with. Okay, yeah. No. 2 will not necessarily always be on the inside. Any other questions on that? Do you want me to just give you a radical to simplify to see if you can do it? Yeah? Okay. How about nope, that's not a good one either. Try that one. Okay, how about you simplify the square root of 48? Yeah, wherever. Just on your pink piece of paper somewhere, just so you can practice simplifying the radical. Huh? You can. Whatever you want. Two numbers that multiply to 48. Did I hear?
24 and 2.
Oh, I heard 24 and 2. Okay. 6 and 8 works. Okay. Doesn't matter what you choose as long as it actually multiplies to 48. 24 breaks down. I'm going to do 6 and 4. 2 and 3. 2 and 2. It doesn't matter how you break it down because you are breaking it down to prime numbers. You will all end up with the same prime numbers at the end. Okay, I need everyone to stop talking, please. What do I have pairs of? I have a pair of 2s and another pair of 2s. Did you see both of those? Okay, so each pair comes out. So this pair comes out, that pair comes out. What's left over?
3.
The 3. So your answer should have been 4 square root of 3.
Oh. Oh, if they're 2 of the same pair, you know.
You still, okay, so if they're 2 of the same pairs, they are still each coming out. I need everybody to stop talking. While I'm talking, you should not be. Every time there's a pair, each of them comes out. So this pair comes out, and then that pair comes out. It doesn't matter if they're the same or different.
Oh, but
Each pair has to come out.
it wouldn't be like 2 times 2 times 2 times 2.
No, because remember, they're coming out and going on one date together.
Okay.
So these two people go on one date. They're not splitting up. Okay? Questions on that? Okay, so let's move on. Let's look at the midpoint formula. So the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. It is set up with a comma in between because my answer is a point on a graph. You will have an x-coordinate and you will have a y-coordinate. Okay? Same thing though, we need to figure out what our coordinates are. So what is this coordinate down here? -4, -5. Remember x first, then y. What about this top one? -2, 5. And just like before, I recommend that you label your points. x1, y1, x2, Y2.
Is -3, 0.
Okay, but you need to solve it. I agree with you, it is. But we're going to actually solve it because you won't always have a graph. Okay? What is a midpoint?
The middle between the
The
points.
middle, the point that is in the middle of the line, right? Or segment. So let's plug everything in based on what we have labeled. So -4 plus -2 divided by 2 and -5 plus 5 divided by 2. -4 plus -2 is a -6, and -6 divided by 2 is -3. -5 plus 5, 0. 0 divided by 2, 0.
Where does the 2 come from?
Because it's halfway between, so we're dividing by 2. That's part of the formula right here, babe. Okay. If you were to plot that on the graph, That's negative 3, 0. So some of these you will be able to look at and see, but I will expect that you do the math to show that that's the case. Sometimes you won't even be given a graph, so you have to use a midpoint formula. Okay? I would like you to do number 7, please. So figure out what those coordinates are and find the midpoint. You should have gotten the points 2, 1 and negative 5, 5. When you plug everything in, you end up with negative 3 over 2 and 6 over 2. I want negative 3 over 2 to be a decimal just because it'll be easier for me to graph. What is negative 3/2 as a decimal? Negative 1.5. And 6 divided by 2 is 3. So if I go to plot that on the graph and I go over negative 1.5 and up 3, as long as it lands on that line, I'm good. So if you have a graph, that's a way to check your work. Make sure your math is correct. Because if it's not even on the line, then you did something wrong. When do I not have to, if I have a graph, when do I not have to use the midpoint formula for sure? Like when can I for sure count and I know it's going to be 100% accurate?
When the two x's and y's are the same.
Okay, so if the
Make it
x's,
opposite.
so if the x's or the y's are the same, so if I have what type of lines?
If it's straight line.
It's only one line. What kind of line? There's 2 answers, but it's one kind of line. What kind of line is this? Horizontal line. Can I also have a vertical line? Because here I can easily count boxes. I know that that box, those are 4, that, let me try that again. I know that that segment is 4 units long, which means halfway in between it is 2. If you have a vertical line, it's the same thing. You can count the boxes. If you have a line that is diagonal, you have to use the formula. Questions on that? Okay, before we move on to the back, I need you to go back to your important formulas page. Just flip back in your notebook. You don't have to do anything. What's the first formula that we've been dealing with that you should put in there? Slope. So you can write this however you want because this page is for you. So if you want to box each of these, if you want to write them in order, like I don't care how you write it, but here's all the formulas right now that we have used. So you have slope formula, you have the distance formula, and you have the midpoint formula. IM2 this semester has a ton of formulas. So take a second and get all of those in there. Okay. So we are going to position an isosceles triangle on the coordinate plane that has side lengths of 12, 10, and 10. What makes it isosceles? 2 sides that are equal. Okay. This part here is important, what's bolded at the top. Center the long side on the y-axis at the origin. Okay? Sorry, the x-axis at the origin. So what is my long side? 12. So I need to center a 12-unit segment on the x-axis. So what does that mean? Where would I go from? Where would I start and end? I would start at 6 and end at -6. That's 12 units long, right? And it's centered in the middle. Do you agree with that? Yeah? Okay. So draw in that line. Now, my 2 sides are going to be 10 units long. Do you think that it's as easy as putting a dot at the 10 and saying that's 10 units? No, because it's not. There was another formula on the front side that we did not use yet. What was that formula? Pythagorean theorem, right? Pythagorean theorem is a squared plus b squared equals c squared. Who knows when to use or when we can use the Pythagorean theorem?
Triangle.
It's okay, I didn't hear anybody else. A right triangle. So if you have a right triangle and you are solving for one of the side lengths, you're going to use the Pythagorean theorem. Does anybody see where I can potentially create a right triangle?
Oh,
Okay, so let me ask you another question. I'm going to draw a side length somewhere up here, right? Do you agree with that? That's going to be my hypotenuse. What is the length of the hypotenuse going to be? 10. We know it's going to be 10. It tells us that. Which one of these, A, B, and C, is the hypotenuse? C. So I know C is going to be 10. I just have to figure out what A and B are. So if I have a hypotenuse drawn in here, and I know that's 10, does anyone see where I can create a right triangle?
okay.
What if I draw a line here? Do you see a right triangle? So if I went here to here, see that right triangle? So I don't know how high I'm going, right? That's what I'm trying to figure out. So I'm going to call that my B. What is the length of A from here to here? 6. So I know my hypotenuse was 10 because that's what they told me. B I'm trying to figure out, and then I know this part of the segment is 6. Can I now solve that? One more time. I got a what? Okay. Are you okay with the hypotenuse being 10? Yeah? If I were to draw in, so if this becomes my right triangle, right, I just have a hypotenuse like this. I'm trying to figure out where my hypotenuse is going to hit here. So that I'm calling my B length. I don't know it. From here to here is 6 units, because you only can use the Pythagorean theorem with right triangles. So if I solve, 36 plus B squared equals 100. If I subtract 36 from both sides, I get 64. And how do I get B by itself?
You do the square root of 64.
Good. Take the square root of both sides, so that means B equals 8. Means I can place a point at 8, and now this distance has a length of 10 units. This has the length of 10. These two sides are the congruent sides. That's my isosceles triangle.